All right, welcome to this episode of The World Around Us. We're going to try to do some stoichiometry. We're going to go from grams of reactant. What do we need for the other one? So you're going to get a question like, if you begin with so many grams of this one thing, and you have a complete reaction, how many grams of the other thing do you need, or how many grams of product will be produced, or something along those lines. So that's the kind of question. We're going to do a grams to grams. We're going to do all grams. We're going to talk a little bit about the process. I have pre-mathed some of the things. Mathed. I use math as a verb. I have done the pre-math. The question is not, will I make mistakes in this video? The question is, how many will I make, and will you find them? Let's find out. We're going to assume, if you're doing stoichiometry, we're going to assume that you know how to balance an equation. That is the very first step of getting this whole thing done, because those coefficients are vital in the process. So we're going to begin with a balanced equation, and we're going to use chlorine and iron. So we take chlorine, Cl, plus Fe, and that yields, I'm going to get a different Sharpie, one that has a sharp point. That yields Fe, Cl3. Now we balance this out. It is Cl2 to start with. Chlorine is one of the diatomics. Balancing it out, we're going to get 3. That's 3, and then that'll be a 2, and that will be a 2. So our coefficients are 3, 2, 2. That's our balanced equation. We also need some scratch work. We're going to need the molecular masses. We need the molecular masses. So this is before we even think about stoichiometry, or maybe when we first go, oh my gosh, grams, I'm going to need the molecular masses. The molecular mass of iron, we're going to go with 55.9. I'm just going to put molar mass here. If you are new to the channel, if you're new to the videos, I type all this out so you can actually read it. Molecular mass, and also my handwriting. The molecular mass of a chlorine atom is 35.5, meaning that the molecular mass for Cl2 is 71, because that's 70, and yeah. And the molecular mass for the compound FeCl3, the molecular mass for that is 162.4. All right, that's the beginning point. That's where we start. This is the scratch work that we need in order to do the problem. So I'm going to Uchi that over to the side, and I'm going to begin the stoichiometry. Beginning with 7.1 grams of chlorine gas. So I'm going to put here given 7.1 grams of Cl2. Find how many grams of iron and how much product will be produced. Find grams, Fe, and product. So we're starting with 7.1 grams of chlorine. And we're going to try to find out, if I'm going to get 7.1 grams of chlorine, how much iron do I need? Now, I need to say at this point, we can work with grams to grams and all of that stuff, but it's so much easier to work with moles to moles, to use a mole to mole ratio. And we're going to take the coefficients of that balanced equation. We're going to take these coefficients. That is our molar ratio. That is the recipe for the compound. If I have 3 of these, and 2 of these, I can make 2 of those. If I have 3 of these and 2 of these, I can make 2 of those. If I have 6 of these and 4 of these, I can make 4 of those. It is a ratio, and it's going to be consistent all the way through. So I'm going to take those coefficients, and I'm going to create a recipe out of that, a recipe. 3 to 2, and I like to draw the yield sign just so that I kind of keep up with things. 3 moles of this, 2 moles of this will create 2 moles of that. But I don't have 3 moles to start with. How many moles do I have? How many moles do I have? All right, so now we're going over here, and we're gonna draw a little line here because we're gonna do some more scratch work on the side. The question says I have 7.1 grams of chlorine. 7.1 grams of chlorine. I need that to be moles. So if I'm going from grams to moles, I divide. So moles, M-O-L, moles equals grams divided by molar mass. So the number of moles that I have is 7.1 divided by 71. Wonder why that comes out so even. 0.1. I have a tenth of a mole. I have a tenth of a mole. 1/10. I have a little bit. The recipe says I need a 3 to 2 to 2 ratio. So that means that if I have 3 of these, I need 2 of these. If I have 30 of these, I need 20 of these. Well, what if I have 0.1 of these? Well, if I have 30 of these, I have 10 times as much as I need. So I take 10 divided by 3. So if I have 30 of these, I take 30 divided by 3. That gives me 10. I have 10 times as much as I need. I multiply everything by that, so it's 30, 20, 20. If I have 15 of these, 15 divided by 3 is 5. I have 5 times as much as I need. 5. So 5 times 3 is 15. 5 times 2 is 10. 5 times 2 is 10. So it would be 15, 10, 10. If I have 3, 3 divided by 3 is 1. 1 times 2 is 2. 1 times 2 is 2. See what's happening? We're taking what is given, dividing by the recipe. If you cook a lot, you do this all the time. If you're trying to make pancakes for 27 people and your recipe is pancakes for 13 and a half people, I don't know why you would have that recipe, but if you did, you would just double everything. Ratio, recipe. This is the key point. The next step is where most of my students are falling apart, is going from, I got 0.1 and I'm supposed to have 3. What am I supposed to do now? I'm going to insert here another comment. There's more ways to get to the number of moles. So this part over here, I'm going to get my purple highlighter. This is the grams version. This is the grams version. If you have gas, it could be given to you in liters. And if it's given to you in liters, then you're going to convert a different way. 22.4 liters is 1 mole at standard temperature and pressure. If you're given a solution, molarity comes in, where you have molarity is the number of moles divided by the volume in liters. So we can get to moles in N equals 0.1, the number of moles, several different ways. This is the grams molecular mass way. So I have 0.1 moles. The recipe calls for 3. Am I being redundant? Yes, I'm trying to drive home the point. If I had 1.5 moles, 1.5 divided by 3 is a half. So I have half as much as I need. So 1.5 divided by 3 is a half. A half times 2 is 1. A half times 2 is 1. If I had 1.5 moles, then I would have the ratio of 1.5, 1, 1. And I can keep going down. If I have 0.1, then what do I do? So this is my way of saying it. Take what you've got, divide it by what you were supposed to have, and then multiply everything by that new number. And I call that the ratio multiplier. So what have I got? 0.1 divided by 3. So I'm going to come over here and I'm going to do a little line here, and I'm going to say my multiplier, and I'm going to call it x, because x is a symbol for multiplication. My multiplier is 0.1 divided by 3. This is a calculator. I dare not try to do that in my head. There's going to be a bunch of 3's out there. 0.1 divided by 3. And I get 0.03333. So x equals 0.0333, all that. Repeated. This is the card filled up. My battery didn't die this time, but the card filled up. I add that to your list of mistakes. Somewhere along the way we were talking about, we have 0.1 and we divide that by 3 because 3 is what we expected, 0.1 is what we have. Take what you've got, divide it by what you expected, whatever the recipe calls for, multiply everything by that. So I'm going to call my multiplier, I'm calling it my x, because x is the symbol for multiplication. I said that. I don't know if it got recorded or not, but I said it. 0.0333. That's the decimal amount that I was supposed to have. It's not 0.5 as much, it's not 0.3 as much, it's not 0.0. That's it. I'm going to multiply everything by that number. So I'm going to come over here and I'm going to do 0.333. And I'm going to put a little line here. I don't know, just so. And I'm going to put my ratio over here. And I'm going to multiply this through. So I know what this number is. 3333. There's a 0 point. No. Mistake. There's another mistake. Left the decimal out. I know what this is. That's going to be 1. That's going to be 0.1. Because that's where I got it from. Now I'm going to do 0.3333 times 2. And that's going to be 0.066666. And then since 2 times this, it's going to be the same number. So I have 0.1 is given. If I have 0.1, then I need, so I took the amount that I was given times everything, and that gives me this new ratio. This is the new ratio that I'm actually working with. Because I only have 7.1 grams, I don't have 71 grams, I don't need that same amount of iron as if I had the full amount. Now I'm going to take these numbers. In order to go from moles to grams, I'm just going to multiply by the molecular masses. I'm going to take this number, and I'm going to multiply times the molecular masses. So I'm going to grab my blue Sharpie. Since I highlighted that in blue, I have 0.1, and that's going to be what I multiply the chlorine by. So it's going to be 71.0 times 0.1. So the next step is to figure out how much iron we need. And we're going to take the 55.9 times 0.0. There's another mistake. 0.0666. And that will give us the amount of iron. And then we're going to take the mass of the compound, which we calculated in our scratch work, to be 162.4. And we're going to multiply that by 0.0666. All right, so we took the molecular masses and then we took our converted recipe. We took our converted recipe and that's what we're going to multiply. We're going to take the molecular masses times that converted recipe. And remember, we got this by taking this number, the factor of what we actually have of the chlorine, times the coefficients. So it's the coefficients times this number, and I will highlight that. And that goes over here. Now all we have to do is calculate. This had better come back to be the same as the number we started with, or else something, bizarre occurred, mathematically incorrect. 71, I'll just put that on the calculator so we can all see it together. 71 times 0.1, bam, 7.1. 55.9. 55.9 times 0.0666. 30 is 3.7. And then clear 162.4 times 0.0666 is 10.8. If you're looking at the math real carefully, you're going to notice that where's a color I haven't yet used. This is the product side and the reactant side. 7.1 plus 3.7 is 10.8. The mass should be conserved across the yield sign. The mass of the reactants is equal to the mass of the product. Now, that's not really part of the question. The question was how much iron do we need, and that's 3.7, and how much product will be produced, and that's 10.8. This is the way you do the grams to grams thing. If you were given liters, you would do this, you would come up with an N, and then you would do this, and then you would do this. If you were given molarity, you would come up with N, and then you would do this, and then you would do this. This part of getting the molecular mass into moles is one way of getting moles. After you have moles, this, all the same. Balanced equation. How much do I actually have? I was supposed to have 3 and I have 0.1. Multiply everything by that. 0.1 times this, 0.003 times this is 0.1. 0.003 times 2 is 0.003. Same. We're taking this number, multiplying through the coefficients. Next, we take the molecular masses, which we did on our scrap paper. We did it over here on the side scratch work. Take our molecular masses, multiply those by, boom, and we're done. One of the complicating factors is remembering what goes with what. And if you have your balanced equation, on somewhere, there's your balanced equation. Now you're going to know the 3 goes with the chlorine. That's it. There's a lot of steps. The students that I'm working stoichiometry with, they can do this part. They can do the balancing equation part. They can do the molecular mass part. They can multiply. It's just putting all these steps together in a sequence and getting that sequence correct. That's the challenging part. And trying to show it all out and try to explain it. There's an ergonomics to this that I'm comfortable with. You may need to find your own ergonomics of where do you put your scratch work in relationship to your coefficients. I don't know. All right, I'm going to call this an end. Hopefully this is something that you can follow through. And I've done, I did it on the screen. You can see how I wrote it out, but also I've typed it out in the text boxes. Hopefully this helps you see how all these numbers work together. The big challenge is understanding this part and going from here to here. And I really feel like this is the thing, this going from I have 0.1 moles, what do I do with that? And that's where this comes in. That's where this piece, I spend a lot of time talking about 30s and 20s and 15s because this ratio drives down to the grams. if you have an idea of how to say this in a different way, put it in the chat, in the text or comment down, in the comment section. Say how maybe you would say this differently. That would be maybe helpful to people who are trying to make sense of this stoichiometry thing. I could do examples with liters of gas. In fact, we could do some liters of chlorine, and if we had 2.24 liters of chlorine, we would get exactly the same thing, because we could go from liters, divide by 22.4, and get the 0.1. If we had some sort of a solution, if we were working with a solution, we could take the molarity times the volume, and that would give us the number of moles as well. So we can get this number several ways. So if we had molarity or gas or grams, we can get to this number of moles. I don't know. It's a complicated, many-step process, but once you break it all down, it comes down to a lot of dividing, multiplying. After you get that balanced equation, which you should be able to balance equations if you're trying to do stoichiometry in the first place. I'm going to stop talking now. Also, if you counted mistakes that I made anywhere throughout the process, leave a comment and say the total mistake count was. We got at least the decimal place here, and whatever went on with the ink pen here, at least 2. I'm sure there's more. Thanks for watching. Click the like button, subscribe to the channel, sign up for notifications, leave me a comment, question, or suggestion. And if you have if you'd like to see another example of this, I'll be happy to make videos as much as you want. See you in the next episode. Thanks for watching.